Hello class, we are in section 7.6 looking at normal approximation to the binomial distribution. Turn to textbook page 344 and let's look at this information right quick. It says consider a binomial distribution where n equal the number of trials, r equal number of successes, p equal the probability of success on a single trial, Q equals 1 minus P, the probability of failure on a single trial. It says that if NP is greater than 5 and NQ is greater than 5, then R has a binomial distribution that is approximated by a normal distribution with mean equal NP or mu equal NP and sigma, your standard deviation, equals the square root of NPQ. And these are your population mean and your population standard deviation. And it says, note as n increases, the approximation becomes better. So on this example, I want to talk about the example that says equal. It says exactly. This keyword, you have to complete the task just a little bit different. So I do want to talk about this problem. The question says, assume that 6% of American drivers text while driving. If 300 drivers are selected at random, find the probability that exactly, it doesn't say at least or at most, it says exactly 25 say they text while driving. Use normal approximation, and you can also solve the problem with Desmos and the z-score table. So I want to show you how to complete this problem using Desmos. As you can see, our answer to this question is 0.0227. So this is the probability that exactly 25 texts while driving. The first thing I need to do is identify my different variables. So if we go back to page 344, let's identify what we need. We know that n is 300 drivers. We know that R is the number of successes. So in this case, my R is 25. P represents my probability. And it says 6%. So we have 6%, which in decimal is 0.06. And we know Q represents the failures, which is 1 minus P, which is equal to 1 minus 0.06. So Q equals 0.94, or we know 94%. But I do want to, when I'm doing my calculations, I want to convert those percentages to decimal. So very important that you know that. So let's read the question again. Make sure you understand how we identify N, R, P, and Q. N is our total number. R is the number of successes. P is the probability, which is 6%. And we know Q is the failures of the probability, which will be 94%. Very easy. The only part that is tricky is when it says exactly 25. So I need to know, how do I set up that probability? So we're going to say P is R equal 25. When I have equal, I do need to set some parameters. And I need to set parameters so that when I input on Desmos, and if I was to use my z-score, I know where to find the certain information. So you have to set parameters around this one. Basically, you need to find an upper lower bound. We're going to say that we have the probability of 24.5 is less than R. And we know R is 25. That's the given. Less than 25.5. So we're going to say, we're basically saying that 25 is between 24.5 and 25.5. So we are almost done. On Desmos, the only thing we need is we need to find our population mean and our population standard deviation. And once we find those two informations, and we also need to find our parameters, which is the 24.5 and the 25.5. Once we have those key pieces of information, we can input the data into Desmos and find our answer to our problem. Let's start by finding our population mean. And those population mean, we're going to take n, which is that total, times that probability. N is equal to 300. And our P is 0.06. And that equals 18. So make sure you understand how I've identified my N and my P. And we calculate that on the calculator, and you should get 18. Let's now find our standard deviation. These formulas are on page 344. Standard deviation is the square root of NP times Q. We know that variance is the standard deviation squared. So remember that we have standard deviation. If you hear the word variance, you know that's just your standard deviation squared. My N again is 300 times my P, which is 0.06, times my Q, which is my failures, which is 0.94. Let's practice typing it in on Desmos right quick. So I'm on my Desmos scientific calculator here. I'm going to hit the square root button. I'm going to say 300 times 0.06 times 0.94. And I have my answer, 4.1133976. And that is my standard deviation. I want to input all those numbers because when I do Desmos, I want to get as close to my answer as possible. So we're going to type in all of that information. We have 4.1133976. Now you do want to go through the next step. It says that if NP is greater than 5 and NQ is greater than 5, then R has a binomial distribution that is approximated by a normal distribution. So we do want to make sure that those statements are true before I even went to finding the mean and standard deviation. But I already know it's true. But we have NP, which equaled 18, and we know that's greater than 5. That is a true statement. And then you take your N times your Q. So we know N was 300 times 0.94. And that's equal to 282. And that's also greater than 5. And that's a true statement too. So because those statements are true, that means I can proceed to finding my population mean and my population standard deviation. So very important that you do test out your answer to make sure that it's right before you go on. Going back to the question, just want to make sure we see our key points. We see that N is 300. R is 25, P is 0.06, and my Q was 0.94. The key word here was exactly. So because it's exactly, I do need to set some parameters. I have the probability of my number of successes equal to 25. And we did 0.5 below, 0.5 above. What other example do you remember us doing our bounds like that? Think about that. Okay, so now I want us to go on. We have everything we need. And I want to now go on Desmos to look at how to find this answer. And the question says they want to know, find a probability that exactly 25 say they text while driving. And we already see the answer is 0.027 in decimal. Convert that to a percentage, and that tells you how many people text while driving. 25 of those text while driving. I'm going to the Desmos scientific calculator. As you can see, I already have the answers input in here, but I want to go through the process again. we are looking at a normal distribution table on Desmos. Notice that they gave me the mean. All I needed was the mean and the standard deviation. And as you can see, I needed those parameters because we said exactly. So I did need my parameters to go in for my max and min. Let's type this in and see how we get this answer. I'm going to click on functions. And you have a tab at the top that says distribution. And we're going to click on normal distribution. You can also start typing in normal distribution. So you start typing, notice it's italicized because it doesn't understand the command yet. Once it understands the command, it comes off the italics. So you can type it in or you can input it. But you need to do the functions because you have to work that a little bit differently. So definitely use the functions tab on Desmos. Now, we're going to input the mean. I already have my answers right here in front of me, so I'm just going to copy what I see. My mean, which we calculated, was 18, comma, and then our standard deviation, we also calculated. I want to input that entire answer. So, and you can round it off. It'll throw your answer off just a little bit, but you'll be able to figure out which answer to match it up with, and you'll be fine. So I have 4.11339276. Notice nothing popped up. Nothing popped up yet. Because on my first line, I do see my answer, which is the answer that you see on a puzzle. But let's see how to find this answer. I'm going to click on where it says find the cumulative probability. And nothing still popped up. It only said equals 1. Okay. And think about the norm probability, what the mean and standard deviation looks like on that curve. I do want to say I have to set my parameters because it's exactly. I just do my parameters 24.5 and then 25.5. And there it is. That's my answer. Notice on your graph is flat. I want to see what the graph looks like. Hit that plus sign. And it shows me what the graph looks like. And it shows you where it's shaded as well. And notice it's shaded exactly on 25. It's right on 25 shaded. Very good. So it tells you that percentage of people the percentage of the 25, exactly 25 people that text and drive. This is what this answer tell me. So doing it on Desmos, you need to find your mean. You need to find your standard deviation. If it says exactly, you have to set some parameters. So do 0.5 below, 0.5 above, whatever that numerical value is. On Desmos, I do want you to notice the answer says 0.0229. On the Ed puzzle, it's slightly off. It says 0.0227. But looking at the answer choices, you can figure out which one to mark. That is it for this example on how to find a normal approximation to a binomial distribution. So definitely practice on how to work it out when it says exactly. You do have examples in the book where it shows you how to use it when it's at least some number. Look at those examples as well. When it's exactly, you have to look at more than one z-score, but when it's at least, at most, you look at one z-score. So that's why this one is just a little bit more work. But on all these, you can still use Desmos to calculate what the answer is. Any questions or concerns, please let me know.